Yeah, this is really important. This is some footage that was shot about 2 years ago in Santa Barbara, California, off the beach. And let's just zoom right into it and take a quick look. So this is another version of the oil rig observation. So the camera is placed in the guard railing between cafe and restroom showers, and you're going to look here. When we look at the elevation, it is set at 8 feet. So Google Earth reads this as 8 feet off of the water, which is a little higher than the 1 foot camera stuff that we did earlier. And then we're going to draw a line to the first platform, which is called platform C, which is directly out in front of it. And then another one a little bit off to the right, which is platform habitat. And when we pull back and look at the distances of these two, we will notice the curve calculator, just to pull that up real fast. And then, remember, this was shot October 23rd, 2017, so over 2 years ago at sunrise. The first one is at a distance of 6.08 miles, platform C. And then the second one, off the distance platform habitat, at 10.1 miles. Why are these two important? Well, because at 8 foot elevation, the globe Earth's horizon should be less than 3.5 miles. Meaning the horizon should be in front of these things. 29 feet of habitat should be blocked by the curvature in front of these objects. And yet, all of the habitat is visible, even with some compression. And you'll notice, and we'll draw a line here in a second, that the horizon is clearly behind these objects. And what makes this footage and all footage like it so important is that these are static objects, meaning these are not boats. These are always in one place. They're not moving or floating anywhere. And we'll draw the green line on this, and you can see, again, it's not hard to see. Somewhere way off in the distance is the horizon, way further than 10.1 miles. And that should not be. There's no curvature. I mean, and that only happens on a flat world. You will not see this on a curved thing, because eventually these objects should be over the side of the hill. They should be behind the curve. And we just don't see that. These two oil platforms, again, one at 6 and one at 10, are right in front. So tell me optically how that happens. Tell me what atmospheric condition can put the horizon behind these objects. You want to say it's a mirage? Okay, well, if you do that, you can never say that a boat is being chopped in half by the horizon. Because you say, well, no, that's real. A boat being chopped in half by the horizon line, with heavy compression and refraction. Oh, no, that's real. But this right here, sunrise, couldn't be clearer conditions. Not a cloud in the sky, shooting off at oil platforms at 6 miles and 10 miles, respectively. You can't tell me that this is a mirage. No way. And even if you do say it's a mirage, tell me how a mirage puts the horizon behind the objects. That's the big key here. Do this with any sort of piece of paper. Bend it in half. Put 2 dots on the other side. Tell me how the horizon is behind those dots. If it's a globe, it cannot be. So again, share this with your friends. Show people, look, this is one of the globe killers, but it's going to take people a little while to understand it. Which is what you're looking at here is objects that are in front of the horizon, which is clearly a long way behind it. But these objects can't be if it's a globe Earth. Cannot be. The horizon has to be in front of these objects. The curve calculator, which mainstream science declared, that's pretty straightforward. So tell me how that happens. Anyway, share it, guys.